Hi everyone. Alright, my hope is we kind of got an idea in the last section of what logarithms were and how they related to exponential functions. Today I'd like to look at the properties of logarithms. Just some of them at first here. And the log base a of 1. In other words, a to what power would equal 1? Well, in order to equal 1 with a power, that power has to be 0. So the log of any base of 1 is going to be 0. Any defined base, I should say. Now, the log base a of a is equal to 1. I already answered that. I didn't mean to answer that. But a to the first power is equal to a. So what's the power of a that gives you a? It's 1. What's the power of a that gives you a to the x? Well, this power is the actual answer here. And then this kind of goes to follow. Log base a and a to the power are inverse functions. So a and then to the power of log base a, those are inverse functions as well. That would equal x as well. So these kind of are equivalent statements in a different way. And let me look at that. What would that be as an exponential? If I were to take, okay, so this is the power. This is the base. So a to the x power. Well, I'm just getting on a tangent. We'll explore that in a minute here. Okay, let's get to this fourth one here. If the log base a of x is equal to the log base a of y, okay, then this is called a one-to-one function. If we're doing the same thing to x and it equals same, and we do the same thing to y, then x will equal y. And this is called a one-to-one correspondence. So we, okay? Now, I've got a few things to do with that. The log base 9 of 9 is 1. 9 to the first power equals 9. 20 to the power of the log base 20 of 3 is 3. Okay. Now if I were just to set that equal to x, 20 to the log base 20 of 3, and that equals x, then if I were to rewrite this as an exponential, then the log and then the base 20 of x would equal this exponent here, which is the log base 20 of 3. And then I kind of use that one-to-one correspondence. X is 3. So those two kind of cancel each other out. Okay, log base square root of 3. This is a strange base, but it's one that's allowed as long as you're positive with that, is equal to 1. Well, the square root of 3 to what power would equal 1? Well, the answer is 0. Alright, this next one here, solve log base 5 of x squared plus 3 equals log base 5 of 12. We have a one-to-one correspondence because the operation that's being done to both sides is the same. Well, if that's the case, then x squared plus 3 is equal to 12. And if I subtract 3 from both sides, I got x squared equals 9. And then when I take the square root, I got to do positive and negative. X equals positive or negative 3. And if you look at that, negative 3 squared is 9 plus 3 is 12. Positive 3 squared is 9 plus 3 is 12. So those are the two solutions there for that. Alright. Now, my next goal is to kind of flip back and forth and translate all these properties you have to natural logs. And log base A of 1. Well, if it's a natural log, we write natural log of 1. This is log base E. Natural log of 1. So E to what power would equal 1? Well, the answer is 0. The natural log of 1 is 0. If I look at the second property, log base A of A, that would be equivalent. This is log base E. I'm just writing ln for natural log. The natural log of E is 1. E to what power is equal to E? E to the first power is equal to E. And then natural log of E to the power of X will equal X. Okay? This is log base E, remember, of E to the X. And that's just asking E to what power would give us E to the X. Well, that would have to be an X there. And we could write E to the natural log. The power is natural log of E to the X would also equal X. We can do that as well. Let me see. And then there's the one-to-one correspondence is the next one. I'm just flipping back to what you've already written. So if the natural log of X equals the natural log of ln of Y, that implies that X is equal to Y. Okay? Just a few to simplify here. Natural log of E to the 1/3. So E to what power would equal E to the 1/3? This is log base E. So E to the power would equal E to the 1/3. The answer is 1/3. Now this is 5 times the natural log of 1. The natural log of 1 is 0. So it's 5 times 0. That's equal to 0. This is 3/4 times the natural log of E, which is 1. E to the first power is 1. So 3/4 times 1, that is 3/4. And E to the power of the natural log of 7. These two are inverse functions. That answer is 7. And then natural log of x minus 3 equals natural log of 7. This is a one-to-one correspondence here. So x minus 3, it's a one-to-one equation, I should say. I'm going to add 3 to both sides. I get x equals 10. And that's all there is to it. Okay, assignment. Let's talk assignment here. These are not super long problems. I want you to work on pages 378 and 379. And if you get 25 through 32, 61 through 66, and 75 through 78 done, that would be tremendous. So, guys, take care. God bless you. And we'll see you on the next one.